All right, we are at the hour, so let's get started. Welcome to this Blueback Toolbox Awareness webinar, where I will show you how you can streamline your Petrel experience using tools from the toolboxes. My name is Renee Peterson. I have a geology background and I work as a domain expert in Segal. Some practical information before we kick off. The presentation will last around 45 minutes in total. If you have questions to the presentation, please ask them in the questions chat and I will answer the questions at the end of the presentation. 24 hours after the webinar, you will receive an email with a link to a recording of the webinar. The agenda looks like this. I will start by giving you a short introduction to Segal and what we do. Then we will have an introduction to the Blueback Toolbox suite. After that, I will show you some live examples of how Blueback Toolbox tools will streamline your Petrel experience. And at the end of the presentation, we'll have a short Q&A session. Segal is a global tech powerhouse specialized in energy. Our headquarters is Stavanger in Norway. We have offices in 10 countries and 20 cities around the world, and we are close to 1,000 employees worldwide. We have three main business verticals. If we start from the bottom here, our biggest business segment is our vendor-neutral cloud offering that is specially designed for energy companies. Then we have a big consulting department that is specialized in managed IT services, data management, and data science. And the last segment is our software products, where the Blueback Toolbox suite is one of many offerings. In Segal's software portfolio, we offer a diverse range of products and technologies. Starting from the right, we have Energy X, which is a modern software suite for hydrocarbon accounting. Then we have our next-gen geoscience products. Prism is a data science enabler for Petrel and other platforms with a direct connection to the Python environment. Avery is a seismic processing platform with a cutting-edge software architecture that accelerates seismic prospect de-risking. Then we have Sategra, which is a vendor-neutral cloud portal on top of our cloud services, integrating data and domain applications for efficient collaboration. The Segal Data Program offers products and services to organize and enhance your subsurface data landscape for maximum value. And finally, we have the Blueback portfolio that improves Petrel with a range of plugins, including the Blueback Toolbox suite. At the top of this overview of geoscience products, you see the Blueback portfolio with products that fill functionality and technology gaps in Petrel. Today, we are focusing on the Blueback Toolbox suite. The Blueback Toolbox suite is a comprehensive collection of tools designed to streamline and enhance your Petrel workflows, providing extended functionality and improved integration. This collection of small to medium-sized utility tools optimizes the user experience by minimizing mouse clicks, introducing features not available in native Petrel, and addressing common challenges geoscientists face in their daily Petrel workflows. Petrel is the best subsurface platform on the market today. The Blueback Toolbox suite expands Petrel and makes Petrel an even better software platform. The Blueback Toolbox suite has been on the market for more than 10 years and is one of Segal's most popular software products. The Toolbox suite has 5 individual toolboxes that are continuously being developed and expanded. In the latest release, we introduced 5 new tools and a range of enhancements to existing tools. All the tools have been requested by clients. Building functionality based on client needs is a common trademark of all our software products. The tools you get with the Toolbox suite are relatively simple in complexity, but they are highly appreciated by our clients. Here you see a list of the 120 tools distributed in the 5 domain toolboxes: Geology, Geophysics, Reservoir Engineering, Project Management, and Wells Toolbox. Before we go to the live demo, let me summarize the 3 categories where where Blueback Toolbox will streamline your Petrel experience. Blueback Toolbox introduces missing functionality that is not present in native Petrel. These tools let the user stay in Petrel for a variety of operations. Blueback Toolbox improves ergonomics on some standard operations that you otherwise avoid doing because they're very labor intensive. And Blueback Toolbox has tools that mitigates inconveniences that is cause for general frustration. In the demo, I will show examples from the 3 categories, and I will mix in tools from all 5 toolboxes. I picked out 13 examples out of the 120 tools that will give you a feel for how Toolbox is streamlining Petrel. So now let's jump to Petrel. I'll just turn off my camera here. So before we start looking at the individual tools, let me just show you where we access the tools in the different plugins. So here you see the Marina dropdown that appears when you install plugins from Segal. And we click here on the drop-down menu and we go and select Blueback Toolbox. And here in the Marina menu, you have access to all the 120. But for the sake of the flow of this webinar, I've extracted the tools up to this personalized ribbons menu. Kudos to SLB for implementing that, so that it's we avoid clicking too much around in the menu. So I will show you, as I said, tools from the 3 different categories, and we'll start out with tools from the first category, introducing missing functionality. I have picked out 5 examples. So in this demo, I will introduce each tool by asking a question. So here comes the first question. Do you do pressure gradient analysis in Excel or other software and wish you could do it in Petrel? So with the pressure gradient analysis tool, now you can do that exercise inside Petrel. So here you see the menu. It's got lots of options. I'll just give you a quick overview. So I've loaded my pressure points here already. We do that either by importing an ASCII file directly, or we can import those from point well data. So here you see the depth versus pressure plots with different gradient lines plotted on top. We can plot this in overpressure space, and here we can see that we probably have 3 gradients here. So this is just made up data. So of course we have 3 very fine, very good defined gradients here. So let's try and do the gradient regressions, and I'll do that by deactivating all the points and then setting the points for the individual gradient active. So now the first gradient here is active, and I can run that regression. That shows up here, and that shows up as a gas gradient. Those categories are defined by cutoffs on the gradients. Then I deactivate the points again and identify or activate the points for the next gradient, run here, and very conveniently that's shows up as a, see, you can manipulate these as you want. I just wanted to extend this line here a little bit like that. That shows up as an oil gradient, and then the last gradient here like that is a water gradient. And now there's different exercises that we can do. We can, for example, run this scissor here that will then highlight the intersections between the gradients as the estimated contacts. So we have an estimate depth estimate for the oil gas contact and for the oil water contact. We can also go to the next tab here, the pressure map, where we can insert depth map. And here, so you see this is structure map. When we press this button here, then that will be converted to an excess pressure map that will grid the immediate pressure points below this depth surface. And let's say that we had multiple gradients and multiple wells, we could then go in and do some fault segment analysis like this, and then do different fault segments, for example. Pressure and temperature is closely linked. So in this data set, we also have temperature information, so we can go in and run. So we'll just activate all the points and we can run a pressure gradient as well. So here you see the pressure gradient. There's lots of other details of this tool, but now I've given you a quick overview that tells you that you can do a detailed pressure gradient analysis inside of Petrel. Okay, so let me open the layout and ask the next question here. So next question comes, have you ever been asked by a reservoir engineer to calculate vertical hydrocarbon columns in wells from the properties in a 3D simulation model? That's a very difficult task unless the cells in your 3D model, they are completely vertical and the well is just following that pillar of cells. So that is almost impossible. But with the Upscaled log QC, we can go ahead and run that exercise. So as the name indicates, this is a tool that is built for Upscaled log QC, and the tool does that by calculating vertical columns based on well log input and then based on grid input, and then it compares the two columns, sets of columns. But it can also just be used to calculate vertical columns either from wells or from grid properties. So here we go in, select the wells that we want to do this calculation for. So I'll just select these three first C wells, and then I need to specify the grid. And this exercise will already pick out the relevant properties, so net to gross, porosity, saturation, and permeability. And then we can run this calculation. So now the tool has calculated the vertical columns for these three wells based on the cells in a 3D grid. So you can see here we've got the three different spreadsheets. We'll just look at the one for C2. The tool has calculated gross, net, porosity thickness, hydrocarbon pore volume thickness, and permeability thickness. So it's vertical columns, and it's done it per zone and in total. So you can see, like here we have the different columns, and we do not in this case have a very thick hydrocarbon pore volume column. So that was that example that enables you to calculate vertical columns in Petrel based on wells and 3D grid. The next tool here, I'll just need to open a few objects from my well logs, the global well logs. I'll open up statistics for these two gamma ray logs. So the question is, have you ever had the need for normalizing well logs per well in Petrel, for example, between two different generations of gamma ray logs? That is a task that is very, very, very difficult because normalization of well logs has to be done per well. You can't just go ahead and normalize an entire distribution, because then the normalization in the individual wells will be wrong. The log normalization tool in the toolbox allows you to do this per well. So you can see in this example here, I've got two gamma ray logs, two generations of gamma ray logs. So one here that is present in 27 wells with a range from a minimum of 23 to a max of 164. The other generation here is recorded in 80 wells with a minimum of 48 and a max of 88. So the same kind of delta, but different min and maxes. And as a geologist, I know that these wells have been drilled in the exact same geology. So the range here should be more or less the same. And for me to use this entire group of gamma ray logs, I need to go in and normalize one group to the other. So I can go here and go to log normalization, and I will select, I'll do the normalization of these 27 wells to the numbers here down in the other gamma ray log. So I'll pick gamma ray AN. I'll select all the wells where this log is present. The tool is then extracting some statistics from the original distribution. Then we've got different options to do the normalization, and we'll just normalize to this custom minimum and max. So here we'll go and select the minimum 48 and the max 188, and then we can observe the statistics of the normalized distribution and statistics. And here down in this area here, we can go in and make snapshots in the individual wells to see the blue is the original and the orange here is the normalized log. We can then choose to overwrite the existing log, or we can create a new, and in this example here, we'll just create a new. And let me just dig that up here at the bottom of my global well logs and have a look at the statistics. So that's that 27 wells, and we can now see that the minimum is 48 and the max is 188, and it's done that normalization in the individual wells, reading off the initial min and max for the normalization per well. All right, so getting ready for the next tool. Let me open up my layout here. And the question is, do you miss old geoframe functionality in Petrel? For example, the spider lines tool. So we've gotten this question from many of our clients. Could you please build in this tool, or this tool from Geoframe or other older packages? So we recently built in the spider line tool that allows us to kind of build a spider web-like distribution of 2D lines from a 3D cube. So let me open up the tool. Here I will select my 3D cube, the one that we're looking at here. And then I will generate, I'll go in and generate this widget. We want the center of this spider line to sit at this top of this structural surface down here. So I'll just activate this and I'll drag it in here. There we go. And then I will set the number of the side lines to 6. And here I can go and drag the radius of the length of these 2D lines. And I can also manipulate the angle here. It probably doesn't make a big difference. I can choose to generate these as 2D lines or as random lines in the 3D cube. So I'll just do the 2D seismic lines. And I should have scrolled up here to the bottom of my seismic folder, but now you can see here, I've just generated these 6 2D seismic lines that kind of goes through this top structure here. So I need to go in and then rescan these amplitudes for the color scale to adjust. But here you can see that now we've implemented. Then that's a good example of us building in good functionality from some legacy products out there. The last example in this category, let me bring up my layout. So when you have, the question comes here, when you have adjacent or overlapping seismic cubes, do you go to other software platforms to merge these seismic cubes into one big merged seismic cube? With the toolbox, you can do that exercise in Petrel. So in this example here, we have 2 overlapping seismic cubes, one here and one here, and that first one has an area of dead traces. Let's try and open up the merge and resample tool that allows us to do this exercise. And it's already picked a tool, but I'll just do it from scratch. So here we take those seismic cubes and we drop them into the menu here. And you can already see the extent of the first cube. And then we drop in the next one, you see the extent of that. And also these colors here indicate which of the cubes takes priority. So if you want to change that, you can push these cubes up and down in this menu here. You can also display them as time slices. So in this example here, we want this blue cube to take precedence over the green one, but we have dead traces in the blue cube here. So we can go in, specify a polygon for that particular cube with the dead traces. I've digitized this polygon already, and we can go and tell the tool not to use the traces for the first input, but go to the second input for and use those traces. Then it's always a good idea to do amplitude balancing in order to avoid areas of very bright seismic and areas of very dim seismic. So you can see the tool has already calculated the root mean square amplitude for each of the cubes. When we enable this amplitude balancing, the tool goes in, calculates an average between the two, the root mean square average. You can also do median or just an arbitrary number. And then the tool calculates scalars that is applied to the individual cubes to bring them to this new common average. Then we go back, we specify the output format, and then we need to specify the inline crossline geometry of the output cube. So here we would like to use the inline crossline of that secondary cube, the green cube, which is this one. So I'll drop that in. Remember to keep the expand so that it expands to include everything here. We specify the depth interval and the sample interval, and then we click OK, and the tool is just running this merge operation. Of course, this is demo data. If you have big mega cubes, it will take a little while. Sometimes it'll take a day if you have really big cubes, but it will chew through the numbers. Oops, so let's see, it was here new seismic. So now we have generated this new merged cube between that's merged of these two input cubes. That was the last tool in the first category. Moving over to the next example. So now I will show you tools from the second category, tools that will improve your ergonomics, meaning less mouse clicks and less keyboard interaction to run certain operations. And the first example here is, let me just bring up the information that enables me to ask the question. And the question is, do you find it tedious to sample log attributes per zone, per well in standard Petrel? So that was the wrong spreadsheet. Let me just bring up the zone spread here. So what I'm talking about is generating these kind of attributes, the mean porosity per zone, per well, the minimum porosity value, the maximum porosity values, and facies fractions. This is an extremely tedious exercise in Petrel. And with the tool called Quick Mapper, that exercise becomes relatively easy, reducing your mouse clicking quite significantly. So that was the spider lines. Sorry about that. Quick Mapper. Here we go. So with the Quick Mapper here, we go in and select the wells where we want to run this operation. We do not work with well tops, but we work with the derivatives of the well tops, which is the zone log. And this zone log has two levels, so we can go in and choose the level. So now we'll sample continuous log attributes into these 6 zones per all wells. So here we can go in and select multiple continuous logs, permeability, porosity, V-shale, and saturation, for example. And we can also at the same time calculate facies fractions per facies log. So we'll just add 2 facies logs here. Then we select the attribute. So of course, we'd like to know the thickness, the mean value of those continuous logs, minimum, maximum, peak, rolling average, and curve summation. And then immediately we can go ahead and populate those attributes out into 2D grids. So here I'll just specify the gridding settings, and I will click OK. And then down here, you can now see that the tool is calculating these attributes per zone and gridding out those attributes. So the result sits down here at the bottom of the input, and you can see that uh, we have two data objects per zone. So for example, the point sets, this is the individual numbers. So you can see at this point set for one of the zones, we have all the different attributes that we just calculated with very few mouse clicks. And just to show you how many numbers that we're talking about per zone, I can show you this spreadsheet here. We got the permeability attributes, porosity, V shale, water saturation, and then the different facies fraction per facies type in those well logs. And immediately we populated those attributes out into 2D grids. So here we look at the different permeability statistics, porosity statistics. So this is a brilliant tool to kind of go in and identify trends, lateral trends in your data, and you also have the different facies fractions here. So that was the first tool of improving ergonomics. The next one is a relatively simple tool. So the question is, as a geologist, geophysicist, reservoir engineer, we insert pseudo wells all the time. And do you find that exercise of generating pseudo wells a little tedious? Then we have a good solution for you. So here I can zoom in on this the structure here. I'd like to insert some pseudo wells. I can go here to the tool that is called well picker, vertical well picker, and I can insert wells with one click. So you can see here I'm just very easily inserting some vertical wells along this top structure here. So you can see it extends at a certain length above and below the surface that I click on. Of course, those lengths can be adjusted in the settings of this tool. We also have a horizontal well picker. Let me just, that sits right here. That horizontal well picker requires that we go in and specify some geometry. So the length of the horizontal part of the well, the azimuth of the horizontal part of the well, and then a vertical offset we can apply to the clicking. So if I go in here and click here, now I am very easily inserting vertical or horizontal wells. And this is completely horizontal wells. You can kind of bend the horizontal part up or downwards by playing a little bit with the toe inclination. The vertical well picker is workflow enabled. So let's say that I want to go in and build a regular spaced grid of vertical wells. I can then go to the workflow here. Let me just show you. The workflow step looks like this. So here we have the well picking. And if I run that workflow here, you will see that now this workflow is inserting this regular spaced grid of vertical wells. We are currently working on workflow enabling the horizontal wells. You'll probably see that being introduced sometime next year. All right, so the next question requires a different Petrel project. And the question is, when you have the need to copy check shots between wells in Petrel to control your velocity field, do you find it tedious with the export-import workflow of check shots? So with the toolbox, we have a tool that allows you to do that copy of check shots between wells very easily. So in this project here, we have a field where we have time depth relationships defined for most of the wells, but we do have two wells here out on the flanks where we'd like to insert and generate a time depth relationship kind of to control the velocity fields to make sure that the velocities don't go crazy out in these areas. And to do that, we would like to copy. So you can see we've got check shots in this well. We'd like to copy these check shots into these two wells. And doing that without the toolbox is a little bit tedious export import exercise. With the Blueback well data viewer, you can do that exercise in Petrel. So this is the Blueback well data viewer. You got all the wells in the project. We've compiled the different data types, well data types into tabs, and we can go immediately to the time depth relationship tab. And here we can, for example, highlight wells with check shots. That highlights all the wells that has check shots. So you can see, as we see over here, well 1-1 has check shots, but for example, 4-1 does not have any information and 7-1 does not have any information. So if we go to well 1-1 and we click this drop down, we can go in and look at the details of this check shots with the spreadsheet and the different velocities. And now we'd like to copy this check shot set to well uh, 4.1 and 7.1 like this. We've chosen the check shot, and then we hit this button here. We'll then simply copy this check shot set to these wells. So now if I go to well 4.1, it does not have a defined TDR yet, but it now has a check shot set. So here we've conveniently given it copy from a copy from well, and we can choose that, and then we can hit this button, and now we can generate the TDR information from this check shot. And let's do the same thing for well 7.1. Generate the TDR, and then close this menu, and then we can go here, toggle the one-way time, and now you can see that we have TDRs, fake TDRs defined in those two wells so that we can go in and control the velocity field. Back to the other project and open up my layout. So very often in our Petrel windows, 2D and 3D windows, we display a ton of information, and sometimes we like to maintain some data types, but quickly untoggle some other data types. And then the question is, when you want to toggle or untoggle specific data types in Petrel windows, do you find it a little stressful to navigating the different data tabs and scrolling up and down to access those toggle boxes that enables those quick untoggles or toggles of different data types? So we have a little tool that is very helpful for this exercise. It's called Toggle Visible Objects. It was introduced here in the latest release of the toolbox. So let's see how it works. It sits here in the tool palette, toggle visible objects. So in this example here, we have many different data types. So in this case here, we just want to look at the model data, so we can very quickly turn off the seismic and the well data, so the well trajectories and the well tops. We can go to this 2D window, for example, untoggle the points and the polygons and the fault interpretations. Then we can go back to the 3D window, and you can see that the tool remembers what we toggled or untoggled in this, so we can very easily go and toggle those data types back on, and for example, untoggle all the model data in this case. And the same goes when you go back to this window, it remembers what we toggled and untoggled. So that's a very nice feature. Simple, typical toolbox tool. So that was the last example in the second category. Now we're moving on to the third category, where I will show you tools that mitigates general inconveniences. And here again, I've got 4 examples. So again, this is a well log statistics example. So again, I go back to the gamma ray, but now I'm going to open this third gamma ray log. And here we observe some crazy values. So the question here is, when you observe erroneous log distributions in global well log statistics, do you find it hard to identify which wells is causing or has those erroneous logs? So we see we have a gamma ray log, and we have a minimum value of -76 and a maximum value of 888. And we know that this is not correct. So something is wrong in some of the wells, but how do we identify the wells that has this issue? So we can use the log QC tool from the toolbox. Here we'll go in and select the gamma ray log. So that's this log here. It immediately tells us what template and what units to expect. We select all the wells where this log is present. And the tool here is extracting statistics from each log in per well. So you can see here we've got for this well 11, the minimum, the maximum, the mean value, standard deviation, minimum measured depth, and maximum measured depth. And we see that we have some very erroneous values over here. So let's try to identify the wells that has those low values. So you can see here we can run some identifiers based on some cutoffs of the statistical extractions. So in this case here, we can tell the tool to show me all the wells that has a minimum value less than 10. highlight the wells. 3 wells has been highlighted. We'll bring those to the top of the list. And here you see, yes, all right, that looks like the wells with those erroneous minimum values, and they also have some crazy maximum values. So let's try to place those 3 logs, wells and 3 logs into a well section window, so we can see what's going on. And in this case here, we can immediately go in and see, okay, something went crazy wrong with the recording of, so the gamma ray logging tool was probably burnt. So we can't do anything to kind of rescue these logs. So let's go ahead and make sure that they don't mess up our the work that we have to do based on this log. So we'll just simply go ahead and delete them. We update the statistics over here. Now we've taken care of the crazy low values. Now we'll need to look at what wells causing those high values. So in this case here, we'll then change, show me all the wells that has a maximum value higher than 200. Highlight the wells. That is 2 wells. Again, we'll bring those 2 wells to the top of the list, post those directly into a well section window. And in this example here, we can see that this is probably some spikes, some crazy spikes that is going on, which is not unusual, but it looks like we can actually use the rest of the logs. So we'll go in and use the native Petrel despiking tool to kind of despike these, and then we can still use those gamma ray logs in the workflows. All right, so getting ready for the next question. No, sorry about that. Getting ready for the next question. So the question is, when you have finalized your technical work and you're ready to grab screenshots for PowerPoints and reports, do you find that zoom and spin functionality quite annoying? I do. So for this is the kind of the example that I've prepared. I have finalized my geomodeling exercise and I'm ready to take some snapshots for a PowerPoint for a peer review. And I want to start out with the facies model. So I angle my 3D window exactly how I like it. I copy the bitmap and paste it into my PowerPoint. And then I'm ready to do, for example, the porosity like this, and then I accidentally do this. Oh shoot! And then I need to go back, take new shots of my facies and so on and so forth. So kind of to avoid that, we have a very smart but simple and smart tool. So if I go here to the Windows tab, there's this freeze window that kind of freezes the window. I cannot rotate, I cannot zoom, but I can still take my snapshot and I can still change the data and then go to my porosity, take my next snapshot, paste, and take the next the permeability, for example. So that's a very neat little feature. Again, the next tool will just stay in this window. So the question is, do you sometimes miss a scale bar in the 3D window? And here I'm showing again a relatively simple feature, both for reporting snapshots, but also just for your personal kind of dimension reference. It's very nice to have a scale bar in a 3D window. So we've got this tool called the 3D ruler. So I can insert a uh, ruler here at the back end of this of of the facies model here, or the porosity model, and that gives me some dimensions. So laterally we've got about 5 kilometers, and depth wise this is expanding to about 200 meters, and we can insert multiple of these 3D rulers. So if I want to know a little bit about the geometry from this from I don't know what happened here. Let's just get rid of that one. I want to know something about the dimensions from this low to this high. I can drag, insert one of those, and that tells me that the difference between this fault and this fault is about a little less than 2 kilometers, and the depth difference is about 350 meters in this case. And as you saw already, These 3D rulers, they live as objects here in the 3D windows. We can toggle them on and off, and we can share them between different 3D windows. So that takes me to the last example today, and I will open up my layout. So this is an example of a tool that helps seismic interpretation. So the question is, do you find it inconvenient to adjust and fine-tune tracking parameters when you want to interpret weak reflectors? So to illustrate what I'm talking about here, let's try and go in and start interpretation of a weak reflector. So I've inserted a new horizon. Then I go to seismic interpretation and activate the 2D tracking tool in Petrel. And the example, we want to try and track this blue reflector here. I'm using the 2D Petrel tracking tool like that, and you can see it's doing a pretty poor job of tracking this it's weak, but it's still present. So that means that for me to do a better job on that with the native Petrel tool, I need to go in and adjust the tracking parameters on this horizon. Or with the toolbox, I can simply go ahead and activate this what we call smooth interpretation. And then you can see like what I'm doing here allows me to track this blue this blue weak reflector relatively easy, and it's doing a pretty good job. So here, something like this. And if we zoom in, you can see why it's called smooth interpretation. The yellow line here is the actual amplitude tracking, and then the blue line is the resulting smoothed version of that tracking. And we can go in and play with the smoothing. We can do a little bit of adjusting of the smoothing parameters like this. But then you can see again, nice tool that just kind of makes it a lot easier to interpret these weak reflectors. So that was the final example in the live demo. So let me jump back to the PowerPoint here. And summarize what we've just seen, and I will turn on my camera again. So in this webinar and this live demo, we've seen examples of how Blueback Toolbox is making your Petrel workflows more efficient by introducing missing tools that are not present in native Petrel, by improving ergonomics on standard workflows that otherwise are very labor intensive, and by introducing tools that mitigates general inconveniences. If you want to learn more about the Blueback toolboxes and the tools in the toolboxes, please reach out to your local Segal representative or use the email information that is being shared tomorrow. And before we go to the Q&A session, let me remind you that you can meet us at PETEX in London. That is happening next week, November 19 and 20th, where we will be at booth 10. And here you can learn more about the Toolbox tools. You can learn about our new well tie analysis tool. You can learn more about Avery, Prism, and you can also get more information about our Segal data program or anything else that you saw in the introduction page. So now it is time for Q&A. Let me see if we have questions. Oh, the question here is if the webinar is being recorded. And yes, I have already kind of said it's being recorded, and an email is being sent out to all participants. All who registered will receive that email with a recording of this webinar tomorrow. And I have another question here, simple. In which toolbox does the LogQC tool sit? So the LogQC tool sits in the Wells toolbox, and you've seen a few examples of tools from the Wells toolbox, and they Most of those fall into the category of either mitigating inconveniences or reducing mouse button clicks. So you saw the quick mapper, and you saw the log QC tool and the log normalization tool. So that is the end of the list of questions. So for everyone who attended, thank you very much for attending our webinar today, and look forward to receive more information in that email tomorrow. Thank you very much.